Hello students, today we are going to discuss about the topic equilibrium, and before proceeding with the chapter equilibrium we should have some basic knowledge regarding that. So first we will go for the category of reactions. Reactions are of two types, that is reversible and irreversible reactions. Reversible reactions are the chemical reactions in which the products of the reaction can also react with one another to produce back the original reactants, is known as reversible reaction. That is, once the product form also can give back the reactants. Okay, that is what called reversible reactions. Okay, for example, PCl5 solid is giving PCl3 gas plus Cl2 gas is a reversible reaction. That is, decomposition of PCl5 is taking place to give the gaseous component, that is PCl3 as well as Cl2. Again, these two gaseous components are united to give PCl5. The second example you can cite, calcium carbonate. When to dissociate, it also give calcium oxide plus carbon dioxide gas. Again, N2O4 gas. Also on decomposition it is giving 2 nitrogen dioxide gas, which is also a reversible reaction. The fourth reaction we can cite, when ethyl acetate is hydrolyzed, it is giving acetic acid plus ethyl alcohol, is also an example of reversible reaction. That means once the reactants are combining to give the product, also the products do combine to give the reactants. So this is what reversible reaction is about. Okay, and what is called irreversible reaction? Let us see that. So irreversible reaction, I am just going to the definition part of it. The chemical reactions in which the products formed do not react to produce the original reactants are known as irreversible reaction. That means reversible reaction was bidirectional, but here irreversible reaction is unidirectional. Once the products formed cannot be reversed to get back the reactant. Okay, that is what called irreversible reaction. Okay, it is unidirectional. For example, the very familiar example, if people have already gone through this reaction in your lowest standard, that is silver nitrate when reacts with sodium chloride, it is giving silver chloride. The white precipitate of silver chloride is deposited in the bottom part of the test tube and is also forming sodium nitrate. Here, once silver chloride and sodium nitrate formed cannot be combined again to give back silver nitrate as well as sodium chloride. Okay, that is what is written here. Here reverse reaction is not possible, that is AgCl and NaNO3 do not react to produce AgNO3 and NaCl. Also some other examples you can cite here. HCl plus NaOH is giving NaCl plus water. Zinc plus copper sulfate is giving copper plus zinc sulfate. Those reactions cannot be reversed back. Okay, so this is all about reversible as well as irreversible reaction. Now I am going for the characteristics of reversible reaction. That means a reversible reaction carries what are the characters, or a reversible reaction is categorized or characterized by what are the parameters which are just governing a reversible reaction. Okay, so one by one I am just going to give those. So first part is it never proceeds to completion. It never proceeds to completion, is that means a reversible reaction never proceeds for completion. It never completes. Okay, because once the reactants consumed to give the product, okay, other side also the products do react to give the reactant. Hence, it never proceeds for completion. Next, these reactions involving one or more gaseous species take place in closed vessel. This is a more important point, because if, and the second point is saying that whenever any chemical reaction involving gases, okay, are taking place, a reversible reaction involving gases are taking place, it should be done in a closed vessel, because once the vessel is open, means it is giving permission for the system and the surrounding to exchange mass and energy. That is why that means in a reversible reaction, okay, in which gaseous reactants and products are there, even if one gas is present there, then that reaction or that experiment should be carried out in a closed vessel. This is what the second point is saying us. Okay, then the third point I am just citing in front of you. Equilibrium is a state in a reversible reaction at which the molar concentration of the reactants and the products do not change with time. That means at the state of equilibrium, the concentration of reactants as well as products do not change with respect to time period. Okay. Now, what is the meaning of concentration, molar concentration? Molar concentration means number of moles per liter of the solution. Number of moles per liter of the solution either of the reactant side or the product side. That means in gist, equilibrium is that state, okay, or during the state of equilibrium of a reversible reaction, molar concentration of the reactants and products are not changing with respect to time period. Okay. Next point is a reversible reaction attains equilibrium under a given set of conditions. Okay, so let us consider what is the meaning of this fourth point. That means equilibrium is attained under a given set of conditions. Those conditions can be of or taking to concentration, temperature, pressure, etc. Okay, so within or take in its fixed set, under a fixed set of that is conditions, equilibrium is established. This is what the meaning is. Next point, let me cite you. The state of equilibrium can be changed by changing the condition. For example, temperature, pressure, concentration, etc. These are the major factors which are changing the state of equilibrium. Means, state of equilibrium is attained under a given set of conditions with respect to, let it be temperature, pressure and concentration, major parameters. That means, if we are going to have some change in these conditions, then our state of equilibrium will also be changed. This is what the meaning here. Okay. So, this is all about the characteristics of that is reversible reaction. Okay. Or next, I am just going to equilibrium and its dynamic nature. Okay. That means why equilibrium is said to be dynamic in nature. This is what a 2 marks question here. Okay. Now, from physics, you people have must have gone through the word dynamic. Dynamic means in motion. Okay. So, it says that equilibrium and its dynamic nature. That means chemical equilibrium is dynamic in nature. Okay. That means equilibrium is always in motion. What is the meaning of that? We have to explain that. The meaning of equilibrium and its dynamic nature. Okay. I am just going to explain that part. Equilibrium is that state in a reversible reaction at which rate of forward reaction is equals to rate of backward reaction. This is what the exact meaning of equilibrium state. That means in a reversible reaction, both forward and backward reaction taking place, and rate of both the reactions will also have some value. Okay. Now, rate means what? Change of molar concentration with respect to time. So, equilibrium is that state at which rate of forward reaction is equals to rate of backward reaction. Okay. That is rate forward is equal to rate backward. Means that state is called equilibrium state. Okay. Now, why it is called dynamic in nature? Let us focus to that point. Equilibrium in reversible reaction is dynamic in nature. Dynamic means in motion. That is, both forward reaction and backward reaction take place simultaneously, although their rates are equal and opposite. Okay. When a system attains equilibrium, all the measurable properties, for example, temperature, pressure, concentration, density, etc., color also get fixed. Okay. That means at the state of equilibrium, all the measurable properties are fixed. This point we have also discussed in the previous section or previous concept, that equilibrium is attained under a given set of conditions, and if you are going to change the condition, then equilibrium point is also changed. Okay, the state of equilibrium is also going to change. Okay, so that is what the meaning here. And if you see graphically what is the meaning of equilibrium and how dynamic nature is established, we can go through this graph. On taking rate and rate versus time graph of any reversible reaction in which both forward and backward reactions do take place. In this, we can say that from the graph just observe, rate of forward reaction is there, rate of backward reaction is there, and when the point where both the rates are merging, okay, coinciding, that point is called equilibrium point. Getting? So this is what the graphical view of equilibrium, as well as we can employ this graph to explain that equilibrium is dynamic in nature. Chemical equilibrium is dynamic in nature. We can explain taking to this graph also. Okay. Next, but in actual practice, now it appears as if the reaction has come to a standstill. But in actual practice, both forward and reaction, that is backward reaction, proceed at the same rate. Means, let us focus on the definition of equilibrium. Equilibrium is that state at which rate of forward reaction is equal to rate of backward reaction. Okay. Now, that point, that state at which both the rates are equal, we are saying that it is equilibrium. But at that point also, the reaction is not coming to an end. Both forward and backward reactions are going hand in hand. Though these are opposing reactions, forward and backward reactions are opposing reactions. Okay. So, even if equilibrium has established, but the reactions are going on simultaneously in forward as well as in backward direction. That is why equilibrium is dynamic in nature. Okay. Even though it is established, equilibrium is established, but it is not in a standstill condition. The parameters look like in a standstill condition, but this is in actual practice both forward and backward reaction proceed at the same rate. Okay, it never proceed for completion. That is what we have gone through before few minutes. Okay, for example, H2 and I2 combine at the same rate in a closed vessel at which HI is decomposing. For example, H2 plus I2 giving 2HI. Okay, in this reaction, we can get the gist that in the forward reaction, hydrogen and iodine are combining to give hydrogen iodide, and in the reverse, in the backward direction, hydrogen iodide do decompose to give H2 and I2. Okay, so both the opposing reactions are equal and opposite. The rate is going, rate of forward reaction is equal to rate of backward reaction, and the state at which both the rates are equal, then that state is called equilibrium state. Okay, so we can explain that equilibrium is dynamic nature with the help of this graph also. Okay, so whenever this type of question is coming, we can explain in this manner. So here equilibrium and its dynamic nature over. I am just proceeding for the next concept, that is equilibrium involving physical change. Now, physical change means what? Suppose there are, we know that there are three states of matter: solid, liquid and gas. Okay, so whenever there is some change in the states, we call it as physical reactions. Okay, now the state of equilibrium attained in physical processes such as evaporation, fusion, condensation, etc. is called physical equilibrium. For example, solid is converted to liquid. That is, solid and liquid, there is a reversible symbol. Again, liquid converts to gas. Also, solid converts to gas. These three are the reversible reactions in physical change or involving physical change. Okay. For example, in an elaborate form, we can express it. Water solid, that is the ice form, is now in equilibrium with H2O liquid, that is water form, at fusion temperature or at melting point. Okay, that means the rate of fusion is equal to rate of freezing. For the reaction H2O solid to H2O liquid, reversible symbol, we can say that rate of fusion is equivalent to rate of freezing. Similarly, liquid in the form of water is in equilibrium with vapor, its corresponding vapor, is inviting the equilibrium, the processes, that is evaporation process is in equilibrium with condensation process. Just in that same manner, now solid is in equilibrium with its corresponding vapor, means sublimation process is in equilibrium with condensation process, because solid to vapor is sublimation and vapor to solid is condensation. So this is all about the equilibrium which are reflected in physical changes. I hope this is giving you idea about equilibrium and its characters in different concepts. Thank you very much.